right, so hi again, everyone. Thank you for tuning in for our weekly Science Talk webinar series. We are continuing to explore Research Thrust C, which examines how cities can intentionally foster the widespread adoption of infrastructure, development patterns, consumer behaviors, and management practices that advance sustainable water management. Next week, we're actually going to shift gears just a little bit and transition to a presentation from Research Thrust D and learn more about the UN Envision model being developed by colleagues at Oregon State University. As you guys all know, we're recording the webinars and I post them to our YouTube channel, but feel free to keep your mic or turn your mic on and webcam on and post questions in the chat queue, and we can have an engaging discussion at the end of the presentation. So with that, I'm excited to introduce my former CSU colleague and now Western convert, Dr. Alexander Maas, Assistant Professor of Agricultural Economics and Rural Sociology at the University of Idaho. His research areas include the allocation and valuation of scarce resources with a focus on water-related issues. He is an interdisciplinary applied economist with a particular focus on the economic implications of resource management and local policies. So with that, I will hand it over to you, Alex.
That sounded very professional. So today, we're going to talk about sort of a retrospective of the last 5.5 years. During that time, we've been fairly productive. I've worked with 4 students rather closely, 2 master's students and 2 bachelor students that were part of our ERP program. So there's a plug to all of them. They are instrumental in papers that I'm going to present today. And generally speaking, I'd say we were fairly successful in terms of our scientific research publication endeavors. So thanks to the NSF for funding UN, and thanks for UN for funding me. Today, I'm going to try to go through some of these papers and just hit the highlights. So we're going to talk about sort of the basic motivation, the results, and the policy implications. I'm going to breeze through a lot of the methodologies. Obviously, you're free to look at these papers on your own, or if you have any questions and you want some more details about them, hopefully we have time for questions. If not, just send me an email and I'm happy to follow up on anything I talk about today. So the general goal of C41 was to look at financial models and strategies to support the transition to One Water. And as we started pursuing this, I can say that not every project is specifically on topic, but they're all at least adjacent to this topic. And I'm going to talk these through sort of in chronological order. There's a few slight changes there, but mostly chronological. When we think about financial and funding considerations, I'd like to actually separate those two things because we have funding, and what funding is basically costs, revenues, and then service provision. And those are really the only 3 levers we have for funding. Can you raise revenues? Can you reduce costs? Can you change the service that you're providing? For financial considerations, it's much more complicated, and what we learned pretty quickly is actually that some groups are already quite good at this. For example, AWWA has whole seminars with dozens of people who present best practices and all of that. So for today's talk, we're going to avoid getting too deep into the financial stuff, partially because I'm not an accountant, and partially because there are a lot of actual industry groups that are good at this. And then lastly, because it's constantly changing. When we first started this project, there was a lot of uncertainty around the General Accounting Standards Board Statement 34. How are we supposed to take green infrastructure and put it on our balance sheet, right? That was a really difficult thing. That's what a lot of stakeholders were complaining about, one of their biggest problems. And then Statement 62 came out and actually sort of highlighted and went into detail about what that process looked like. So a lot of those questions that started really early on in this project actually sort of worked themselves out in Statement 62. Also, currently, when we're thinking about funding financing green infrastructure, there's a lot of moving parts that are moving right now, so it's hard to say anything definitive. For example, the Environmental Financial Advisory Board is being formed as we speak from the EPA, and their goals are largely to do the things we're talking about when we think about One Water. So I don't know if Christy or anyone else is actually involved in that, but I would be curious. Maybe I'll reach out to you after. And then there's a lot of other financial considerations, right? The problem is a lot of these are sort of case studies by nature. What works for you? So yes, are you going to bond? Are you not going to bond? And then if you are going to bond, there's some best practices around that. For example, a little trick is if you raise your rates before you bond, you actually look better and might get a better bond rating. Things like that. But again, I don't want to go too far into that. We instead sort of looked at a much higher level. So a lot of the, like I said, a lot of the questions that were out there early on were actually cleared up by the implementation guide for GASB 62. We did still, however, try to look across the industry, talking to stakeholders, looking at gray literature, and try to put together trends that we saw in specifically financing. The goal was to move from this service provision to actual resource management, right? How do we get away from this pay-for-service model to one that actually can support One Water? And we did find a few things. Most practices involved some coordination across organizations, whether that's within municipal groups or whether that's outside organizations. That was a huge part of putting together funding and financing, and then obviously grants from higher governments, so on and so forth. Generally speaking, when we think about legacy infrastructure, the financing mechanisms are some version of low-cost loans, tax-exempt municipal bonds, public-private partnerships, state revolving funds, and then to the extent that those also interact with Water Infrastructure Finance and Innovation Act. And when we talk about the financing side of this, I'm going to leave that there, and we're going to jump more to the funding, to the primary science stuff. If any of these resources you're curious about, I can share them or talk in depth about them more. So this is the more sciencey stuff when we think about funding and how we go about estimating how to fund. We're going to start with a paper that was Roshan Puri is a master's student here, was a master's student here. Now he's actually at Virginia Tech pursuing his PhD. And we had this idea that we wanted to evaluate the sensitivity of residential water demand estimation based on model specification choices. So simply put, a lot of what we do in economics and predicting generally is some sort of statistical analysis that looks at demand, where we think of demand as a function of price, and then let's say weather, let's say demographics, and whatever you want X to be, property characteristics, so on and so forth. And we think about this line for two reasons. One, because it really lets us see what the demand response will be and the corresponding consumer surplus gains or losses when we change prices. But it also allows us to predict revenues. So in economic terms, when we think about elasticity, what we're actually saying is the percent change in quantity due to a percent change in price. And what we have is a situation where raising price often increases revenues, as we would expect. If price goes up, sure, we would be getting more revenue, but that's not always the case. In fact, if price goes up and quantity drops enough because people are responding to the price change, then actually we see a situation where revenue goes down. So it's not always clear how a moving price is actually going to affect revenue. For example, if you're on this side of the line, increasing price actually brings your revenues down because people are cutting back proportionally more than the additional revenue you're gaining from that bump in price. And so because we have a lot of these estimates out there, and there's a lot of studies that look at elasticity specifically, we decided to try to holistically look at those and then decide how the choices across all of these studies actually affect our results. So you can imagine if this is our demand line, having some sort of different weather parameterization, let's say you're just looking at precipitation, for example, might sort of shift this and predict a slightly different line than what we had originally. Or if you're thinking about property, maybe the line actually gets shifted out because now we're including acreage, that kind of thing. Maybe the functional form matters if you're predicting this line versus this line. And the truth is this might actually be a better line if we think sort of intuitively about this, because as prices get really, really high, you're still going to have to pay them at least to a certain point, right? You can't stop drinking water, you can't stop showering. So maybe this type of line, this functional form actually makes more sense. And what we did basically is throw the kitchen sink at this function and say, hey, no matter what we do here, what kind of elasticity estimates are popping out? Are we getting consistent estimates? Are they changing drastically depending on what type of variables we included? This gets a little more complicated because, as a lot of you know, we actually have increasing block rate structures in most cities. So that one of the cities that we looked at to do this is just a sample of their block rate structure across years. So at 7,000, they jump up, and then at 13,000, they jump up again. Because of this, there's actually some complications in estimation. I don't want to go too far in it, but you get a weird looking thing where it looks like higher prices are actually creating higher demand, but that's only because these are simultaneously determined in an increasing block rate structure, right? If someone's using a whole lot, they're going to be paying a higher price, which actually sort of violates what we typically think of as the law of demand. You know, when prices go up, people are going to buy less of this. This is sort of a weird world because price is a function of how much you're using. So you have to do some instrumenting here that's a little fancy, and we're going to ignore it for this sake of this talk. But that's one of the things that we were curious about. When we try to instrument this and estimate, are we getting different results? And the good news is, not really. What we walk away from this paper realizing is that so long as you're including reasonable weather metrics, so this is a distribution. Hopefully you guys can all see my mouse. This is a distribution of elasticity estimates conditional on different model specifications. And this one is just around weather as an example. So you can see that if you include temperature metrics, you get some range here, -0.8 to -0.62 or whatever that is. If you include temp and precips, you're getting a different range of potential estimates, right? Highly centered around, let's say, -0.62. If you start including relative humidity, right, you get mostly still in the same area. If you're just including precipitation metrics, it's not a good estimate. Your estimate ends up way too elastic. So sort of this is just our way of testing how consistent are our elasticity estimates when we look at different model specifications. And the truth is really good. We're within -0.8 to -0.6, so long as that we have temperature, some version of temperature and precipitation included. And that gives us pretty good confidence that that's a reasonable estimate. And something similar is true with instrumental variables. So I don't want to go too far into this, but we also see a pretty tight fit regardless of what instrument we use for price. One slight hiccup is that functional form does seem to matter. So if we go back to this, these type of shapes right here, let's call this a log-log model. We do generally get higher elasticities when we're looking at log-log models. But it's not too bad. And so what are the policy implications of this paper? Well, admittedly, not many. This is sort of a statistical endeavor more than it's a policy-based paper. What we do find is that actually parsimonious models predict pretty darn well. You can just use temp and precip. Now, you can throw in a Penman-Monteith, you can try to get some sort of evapotranspiration and wind speed and whatever else you want to throw in here, fine, but it does very little to actually improve the fit of the model when it comes to residential water demand. Turns out that people are generally just responding to price and temperature and precipitation, the end. And how you do the precipitation, whether it's amount per month, whether it's days per month, whether it's single event, cumulative, that kind of thing, doesn't change the results that much around elasticity, which is great, and not particularly much in terms of the actual prediction accuracy for the water demanded also. So that's good. Functional form does matter a bit, so be careful if you're trying to statistically estimate water demand and you want to say, hey, how much is water demand going to change if we increase the price by 5%? The form you pick to make that demand function will actually have an effect on your estimate. All right. getting rid of the more statistical one, let's talk about evaluating the effect of conservation motivations in residential water demand. This was sort of a fortuitous study because we had access to a survey that was just done that asked people about their attitudes towards conservation. And one of the things we wanted to know is, if we're thinking about this one water concept, big picture, do people with different attitudes around, let's say, conservation and the environment or costs, do they behave differently? Specifically, if we know that changes in household consumption patterns driven by extreme heat and drought, which we're all experiencing at record rates nowadays, will affect our supply and demand planning, right? So, sorry, supply and distribution planning. We also know that determining motives for saving water are key when we're designing educational urban saving strategies. So we want to understand how consumption attitudes actually affect demand. And there's just very little work on this out there. So we thought, all right, let's at least plant a flag somewhere and see what our results are. We came up with 3 hypotheses. Households primarily motivated by environmental and social outcomes consume less total water monthly, annually, it doesn't really matter. And then consumers motivated by cost and convenience. And ex ante, there's no reason to think that one of those is going to consume more or less water, right? It could be that people motivated by cost are actually consuming less. It's just because we're setting this up as a hypothesis. We're just picking one of those and saying our hypothesis is that environmental and social folks are going to consume less than cost and convenience folks. And I should also point out that we didn't actually come up with those 2 classifications ex ante. What we did was use a principal component analysis to try to drive people based on underlying use patterns and how they answered survey questions into their own groups. And it sort of broke out into these 2 groups as being sufficiently different based on their survey responses, not so much based on their actual water use. And so then we thought, okay, environmentally and socially conscious consumers will respond less to price changes than cost and convenience consumers, specifically because people who say they're motivated by cost, we could imagine, are going to cut back more when prices go up. And then we didn't really have any prior on identifying who should be more responsive to precipitation and temperature. So we know that during really hot summers, people are going to irrigate more. We know that during really cold summers, people are going to irrigate less. We know that when it's raining a whole lot, some people are probably going to be pretty good at turning off their sprinkler systems. Some people aren't going to care, right? So can we see, based on these sort of classifications, people actually doing different things? And we had access to a survey conducted on behalf of Fort Collins Utilities. There are many more questions on this survey, but the ones that sort of came out that helped us identify these groups are people who are interested in conserving. So rate the level of effort you use to your effort to reduce or minimize the amount of water and electricity that you use. And those are 1 to 5, right? When considering whether to use water or electricity, I consider the environmental impact that my household's water and electricity use will have on the community. Agree, 1 to 5, right? What about your water and electricity use on the community, the economic impact? 1 to 5. How much are you considering cost? 1 to 5. How much are you considering convenience? 1 to 5, right? And so we take those and we sort of separate people out based on what's driving their motivation there. And what we find is that on average, environmentally and socially motivated consumers actually do use considerably less water per person than those motivated by cost and convenience. So it's 1,500 gallons, give or take. It's actually a pretty substantial amount per person. I want to throw a caveat in here. Causal inference about that is really difficult. We have a problem where you could imagine that environmental people are actually having fewer children, right? So now we're having to address the fact that there's kids aren't in the house to use water or to leave the faucet on, right? So there's some sort of endogeneity, what we call endogeneity problem, that does limit our ability to make a causal claim around that. But regardless, that is the result. We do see that there's basically no difference in terms of how people respond to prices. So whether you say you're motivated by the environment, whether you say you're motivated by cost, your proportional reduction due to a price increase is the same. Now, the absolute number is slightly different because we're starting from different averages. But let's say, for example, we increase the price by 5%. An environmentally conscious consumer reduces by 4%. A cost-conscious consumer reduces by 4%. There's no real difference across these groups in terms of how they respond to price. We do see a slight difference in how they respond to temperature and weather. So generally speaking, environmental and socially conscious people, the ones who say that those are their driving factors, are more likely to respond to the weather, right? And again, maybe that's just because they're more in tune to being outside. I don't really know what this is, but when it's very hot, they cut back more proportionally than folks who are motivated by cost. So there is some sort of heterogeneous or variation in responses based on what people's attitudes are around conservation. Even conditional on the fact that both of these groups say that they conserve. In fact, if we go back to this question, rate the level of effort to reduce or minimize the amount of water or electricity use, those averages across those two groups is very similar. There's not much difference. So what are some policy implications about that? Well, first off, decrease the cost and inconveniences associated with conservation. If the goal is conservation, a large portion of people cited those two as driving factors in their water and electricity use. So the more we can eliminate those, the better off we're going to be. Now, this is the second one here is utilities can sponsor education programs and foster environmentally and socially conscious folks. That has the potential to reduce demand, but I'm going to hedge that a little bit and say, again, we don't know if there's something else that's driving people into their environmental motivation and then making them use less, like let's say their preference for children or whatever it is. But certainly there's some implication there that environmentally and socially motivated messaging might reduce water consumption. And then there's actually very little difference in terms of price. So there doesn't seem to be a substantial response difference across motivation, such that utilities gain little by tailoring programs to stated preferences. Overall, there's not much. There is a different sort of mean about what they use to start off with, but that's about it. When you think about price responses, they're very similar. There's a slight difference in weather that we can pick up. But generally, the takeaway message from this paper is ignore what people say. They behave the same way regardless. The next paper we wanted to look at was, or the next phenomenon we wanted to look at was the interaction of electricity and water in the home. And so in econ jargon, what we'd say is that our electricity and water substitutes, complements, or unrelated goods. What that actually means is what happens to water use when we change the price of energy? Right? If electricity goes up, do we see water use go up or down? And the reason we care about that is because if you think about a household, there's certain household production functions, right? Cleaning, for example, where you require different amounts of water and energy. So you could say a dishwasher that uses energy and water. Lights to read, that's just energy. Watering your garden, that's just water. So to what extent are these actually related when we think about household use? And to what extent are they normal or inferior goods? And by that, I mean, if households become wealthier, are they likely to use more or less water? If they're going to use more water, we call that a normal good. When your budget gets bigger, you buy more of that thing. right? There was an idea that these utilities might actually be inferior goods because when you get richer, you can also buy fancy new energy efficient appliances, right? You can put aerators in your faucet, so on and so forth. So we wanted to know how are those things related, and our guess was household electricity and water are related. We don't really know if they're going to be complements or substitutes. We assume that electricity is going to be less price responsive than water. That's just because that's previous work. And sorry about that. And that both goods are normal. So when we increase income, ceteris paribus, we would expect use to go up as well. And so one thing that's interesting across the time period we're looking at is we see a significant increase in electricity bills, even though use isn't going up during this time, the prices were going up much faster than water bills were, right? And part of this is that across this time period, also conservation was occurring. People are actually using less water, and they're using about the same amount of energy, a little bit less, I think. I have to look those numbers up. But. And then we think about, there's another complication in this analysis where electricity spikes both in the winter and in the summer. You'll see electricity is actually spiking twice a year, whereas water is only spiking once a year. So again, I'm sort of ignoring the complications this creates for estimation and just jump into the results here. But there are some interesting things around this, right? Because you can imagine in the summertime when both of these are peaked, that's a much higher actual bill, assuming you're not doing a rolling average, than in the winter time, right? And so we have a lot of control variables in here. Generally, these are in line with what we'd expect. So when temperature goes up, water use goes up, right? That kind of thing. I don't want to spend too much time with that. We do find water is slightly inelastic. Just like our previous paper, these results are clearly in line, right? Negative 0.59, negative 0.78. These are different models. So let's average them to negative 0.65. Hey, that's actually what we got from a different paper. It's again kind of encouraging that we can guess how water demand responds when we change price. So this would say it's inelastic. Electricity is very inelastic, right? This is much lower. You can think about these numbers actually as being the percent change in quantity due to a percent change in price. So if you move up price by 10%, we would only expect quantity to go down by 1.8%. Electricity seems to be very inelastic. And we find that they actually are gross complements. So if you increase energy prices, we see very small reductions in water and vice versa. If you increase water prices, we see small reductions in electricity. We can't really separate out if that's an income effect or if that's because we're using these goods in tandem. What I mean by that is you can imagine if prices for electricity get really expensive, you might use less water for two reasons. You might be not using your dishwasher as much because you're thinking about the electricity, or you might just use less water because now you're spending so much more of your income on electricity that you don't have that available to spend on water, right? So we can't really separate those effects. But we do see that increasing water rates for policy implications here, increasing water rates will increase revenue, not a lot, but slightly. You know, let's say it's, if we take the negative 0.8 estimate, you'll still see a slight increase in revenue. Increasing electricity rates by comparison will lead to a substantial increase in revenue. There is at least substantial evidence, or there's at least sufficient evidence that electricity and water do move together when we change prices. So if we think about pricing strategies from a utility-wide perspective, we should probably do that sort of synergistically. And then unfortunately, the wealth part of this, it's not included in the paper because it was not a clear result. We couldn't really confidently say these goods were normal or inferior. Generally speaking, though, if we looked at households that were wealthier, their water and electricity use was higher. That shouldn't be a surprise. But there's a few things I want to do there because we had a problem sort of just looking at wealthier homes versus specific homes getting wealthier, right? Wealthier homes also have bigger lawns. They have more rooms, that kind of thing. And so we want to know conditional on the same homes getting richer, which you couldn't really work out with this paper. One of the other things we did was look at a very specific area. So this is the Palouse we're looking at here. And for those of you, Mike, you probably know that the aquifer around here has been going down for, I don't know, 50 years or so. I don't know how long it's been going down. So the states, Washington and Idaho, are getting pretty serious about trying to address this issue. So we wanted to know what are preferences for supply alternatives, and how much are people actually interested in providing co-benefits when we're going to do these type of infrastructure investments. So obviously understanding what people prefer can lead to better management decisions, and then understanding how projects generally, in this case it's a water supply project, but how projects generally can be associated with co-benefits, and sort of what the strength of the relationship is there from a consumer perspective. Said differently, it's often very convenient to try to cost minimize if the goal is to supply firm yield water. Great, we can do that at a cost minimum, or we can include co-benefits that might actually cost a little bit more, but because they improve the welfare of all of our citizens, it's actually worth it. And that's not surprisingly the entire idea of One Water. And then we were trying to very specifically estimate what people are willing to pay for different levels of conservation or additional supply or co-benefits, right? So this region, I want to caution that I don't think this is probably nationally representative. We're looking at a very small region in Washington and Idaho, and it's relatively rural. Even though we have 60,000 municipal water users, it's still a relatively rural area. It is growing at about 1% a year, 1 to 2% depending on the year. And so the Palouse Basin Aquifer Committee has been tasked with identifying a new water source or a new method in meeting water demand moving forward. So what we wanted to know is, what are customer preferences for alternative water supplies and conservation strategies? And given new investment, how strong is support to include co-benefits in those investments? And so by co-benefits, we identify wildlife habitat, educational opportunities, recreation, that kind of thing. We basically just surveyed via Qualtrics and in person. So we went around to bowling alleys and farmers markets and on the streets to get people in person. And then we did a Qualtrics to do a broader geographical area. We used a discrete choice experiment specifically because it can limit biases. There's some other advantages there too. But basically when we say discrete choice experiment, we just mean we ask people to pick between different options. So if you had a water supply option 1 that is going to add $30 to your water bill, or water supply option 2 that's going to add $10, right? Water supply option 1 also is going to be treated wastewater reuse, right? Okay, that's option 2 also. But now there's also going to be rebates for upgrade inefficient appliances versus rebates to remove grass. And then is there additional storage involved? In this case, no. And so we sort of cycled through these randomly. And what this allows us to do is, based on this willingness to pay, we can actually back out sort of what people's preferences are and how much they're willing to pay for particular attributes of a water supply project. And I don't want to go too much into the statistics of any of this. So what are the results? Well, firstly, there's strong support for co-benefits in infrastructure projects. When we just ask people how much they support, including particular co-benefits, you can see here recreation opportunities, education opportunities, wildlife habitat, energy requirements. That's actually just one we asked, if we're going to have a new water supply project, how important is it that we minimize energy use around that for environmental reasons. Flooding reduction. People, if we're going to put in infrastructure, we want it to do everything, right? I mean, who doesn't want more for less, right? Generally, there was a fairly strong willingness to pay to improve water storage. to make sure that there's not future shortages. So $14 doesn't sound like a lot, but $14 a month across 60,000 people. I mean, I don't know what that is at a household level. I don't know how big our houses are, but it ends up being quite a bit, right? And that's just one annual amount. So there's a significant amount of willingness to pay here for additional projects. Not so much for monthly rebate programs that are going to induce conservation. So people were fairly lukewarm about any sort of rebate program, whether that's for grass, whether that's for efficient appliances. People weren't willing to increase their bill to do it. And actually that kind of makes sense if you think about it. Why would you increase your own bill for someone else to get a rebate when you could just save up that money and buy your own washing machine? Grass restrictions are a hard no. This is not new to anyone who's worked in utilities. By far, people were most upset when we brought up the idea of water conservation through grass restrictions. There was a slight preference for limiting irrigation by day over actual area restrictions. So when we presented these, we said, okay, as a conservation method, if you have to reduce through grass, it could either be you can only irrigate 3 days a week, or you can't, there's a hard cap on how many square feet of turf you can have. And people were didn't like either option, but they disliked the hard cap on area requirements even more. Also, something that popped out of this that was not intentional, but men are the worst. I don't know if we can say that anymore. They were generally much less willing to pay for anything. Co-benefits, additional storage, they were just cheaper. Yeah, I don't have a more politically correct way to say that. Customers are generally willing to pay for co-benefits. That's a policy implication. That seemed very clear coming out of this research. If you want to do conservation, I know it seems like grass is a great way to go and maybe make them voluntary. Anything that's a prescriptive requirement makes people very angry. Best to avoid those. Generally, anytime we had a bill increase that was less than $10 a month on this survey, people didn't care. Anything below $10, people were sort of willy-nilly about. As you went higher above $10 and those increased, you saw one of them was $30, which is quite a lot actually. People started to get less and less happy about it. But the good news is small movements don't seem to affect people's utility. And then for tailor these messages to women. If men are going to be cheap and not responsive, then maybe a takeaway message is actually tailor some of these conservation and additional programs to women. All right, last paper, and this one isn't actually so much about funding, it's just Katie Burton was our undergraduate research student this year, and she was great. So I wanted to give her a little bit of shout out about with this paper, which was just accepted for publication. And what we're looking at here is property value losses associated with freshwater chemical spills. Sorry, I just read the chat. Specifically, we know that spills and contamination happen. They happen all the time, whether it's the Deepwater Horizon, whether it's things from the toxic release inventory or areas that have been contaminated in some way. They certainly happen. And so our motivation is to look at this and say, we know that there's a history of bankruptcy to avoid cleanup costs. The Gold King mine, for those of you in Colorado, you remember how that happened? Yeah, the EPA ultimately was the one to release some of those chemicals, but they were left over there from mining legacy. We have the same problem here in Coeur d'Alene. So we wanted to look at, hey, what are the actual costs of these spills, these acute spills, not so much the long-term toxic release inventory, but there's been plenty of research around that as well. When we see a contamination, what happens? And in the case of what we're looking at, which is the Elk River, it's actually even more problematic for a utility to think about because the leak at Freedom Industries happened on January 9th. And then the do not drink order came into effect. And then less than 2 weeks later, the do not drink order was lifted. Chemicals were found, some some time after that, but they were at very low levels. But the reason it was a problem from a utilities perspective is because Freedom Industries then declared bankruptcy. They had 25 lawsuits within I think the first month of that spill. They declared bankruptcy, and then ultimately the citizens ended up suing the water utility in the area, which is a whole nother problem. But anyway, so there was a spill. A do not drink order was issued. 10,000 gallons of coal processing chemicals ended up in the river, the Elk River, and 25,000 households had at least mild symptoms. A few, very, very few, but a dozen or so folks had more substantial symptoms. Economic losses in terms of productivity for shutting down for those 11 days were estimated at 61 million. And it was a large area affected, 9 counties, including Charlotte, which is a major city. So this is a map for those of you unfamiliar with the area. We don't really spend much time on that. What we wanted to know is, how does proximity to the Elk River chemical spill affect home prices? Because we don't really have an indication for what the costs are around that spill, one thing we can do is use this non-market method to say, hey, let's look at the homes around there and see what happens to them after this spill. And then to the extent that we can see how long that effect lasts, and does being on a public water supply actually help or hurt? Because you can imagine this world where sure, we've issued a do not drink order. That makes customers say, ooh, I don't really trust my utility. But the alternative is that you're going to have your own water supply and your own treatment, and you can't then spread out the cost of the additional treatment. You might be more concerned about contamination moving forward. So it's unclear ex ante if being on a public water supply should help or hurt. And what we do is basically we break homes into their proximity ring, how close they were to where the spill happened. We also break them up by things like were they waterfront homes, so on and so forth. And we use hedonics. Hedonics is just a way to break up goods into their attributes. So conditional on homes that look the same, they have the same square footage, they have the same number of bedrooms, they're roughly in the same shape. And one's slightly closer and one's slightly further away from that spill, and then they both resell and they both resell. Are there price differentials there that we can attribute to the spill because the houses are similar enough in every other way? And that's basically what hedonics are doing. I would point out that there's some general equilibrium effects here that we sort of ignore, but I don't want to get into that. And so you can see here, before the spill, as we go out before and then after the spill, these trends are pretty consistent. There was one year that seems a bit wonky, but they're pretty consistent up. Seeing these trends, though, aren't really sufficient to decide if there was an effect of the spill, because if you think about control and treatment, if you started off in a different spot, well, here we don't care that treatment went down or that control went up. What we care about is the relative difference between these things. So, for example, if both control and treatment go down, well, treatment here is still worse because it went down even more than control. So again, I don't want to talk too much about the methods here, but we use a difference in difference model to sort of calculate the difference in the difference of these two things across treatment and control groups. It's a better identification strategy generally. We also account for spatial correlation. We all know that neighborhoods have their own attributes that might make them better or worse. So we sort of account for those using spatial correlation, which I'm going to largely ignore. For the rest of this talk, we do get marginal impacts, about 10,700 per additional acre in the area. A house that had a full basement is about $9,000 more. Waterfront properties get a $20,000 bump. Now, 20,000 doesn't sound like that much, but actually this area is a pretty industrial river, so I'm not sure there should be a premium at all for waterfront properties. And then generally, the older homes are less valuable, so on and so forth. And generally, also, it's kind of impressive at how cheap homes are in this area. For those of you who live in, let's say, Fort Collins, Colorado, I don't even want to tell you what the mean home value is in this study. Our R-squared was pretty high, so we're fairly confident in these results. And everything that we did here makes sense, right? It's all in line with what we would expect. And what we back out after we sort of control for all that other stuff that's in there, we are able to back out this, what we call treatment curve based on the distance from the spill. So 1 year from the spill, right, is going to be this guy here, and that's half a mile from the spill. As you go out to a mile, it sort of ends up coming back up to 0, right? By the time you're 4 miles away, there's no real effect here, right? I also want to point out that probably these are a bit exaggerated. Again, this is a functional form thing. We saw very few homes sold within half a mile of the spill. So I'd say I'm very confident in these estimates because there was an end that was high enough within 1 mile. These very few homes were actually sold within a mile of that spill at the time. But what we do back out is that homes after that spill are selling for $25,000 less than they were before that spill happened compared to homes further away. I mean, that's a substantial amount of wealth, particularly given how cheap homes are in this area. I have a lot of questions. Okay, I'm about to be done with this result, and then I'll happily start answering some of these questions. We can go back. So the policy implications are pretty simple. When firms fail, the government collects pennies on the dollar for Superfund sites. We need to come up with a way to internalize the external costs before the spills happen, so that whether that's setting up an escrow account that ensures that liability can be covered. It seems like a reasonable idea. If we think of chemical spills taking up 10 to 20% of someone's home value, that's a huge hit that these citizens had that is no fault of their own. So these are sort of things we need to work on moving forward. And I get that that's not specifically funding and financing water infrastructure, but clearly it's related. Great. Now I will wrap that up. That is 5.5 years of research in UN in 45 minutes or so. I can stop sharing and happily answer questions. Okay.
You want to pop through the chat there, Alex?
Yeah.
So one from Liz, one from
Sure. Liz, the short answer there is that we actually just used an inverse weighting matrix that we truncated at the quarter mile. So any homes within a quarter mile got some relationship to each other. And that relationship got weaker as those homes got further away. And then anything after a quarter mile, there was no relationship, right? I don't know if that's sufficient.
Yeah, did you lag your dependent variable or did you lag some of your independent variables?
Yeah, you can look at, sure.
The different estimation strategies.
Yeah, so we actually played around with that quite a bit. Yeah, you're talking about doing a spatial Durbin versus lagging the error versus lagging the dependent variable. The final choice was to lag the dependent variable and the error, and there's a lot of people who feel very strongly to do one model over the other. They didn't actually affect our results much, so I wasn't too concerned about it.
Okay, thank you.
Yep. How are you, Liz? It's been a long time.
Hanging in there. I think like the rest of us are.
Yeah.
Era of COVID. I think we can now call it an era. It's getting long enough.
Yeah, no joke. Okay.
Yeah, like,
More returning to the second paper with normal or version very good. See at what point increasing water consumption stops increasing quality of life. Yeah, so that's a good question, Alex. Certainly, that's something that I want to explore more. I'll sort of say we were including that in there because I had the idea that, well, I should actually use less water as I get richer because then I can afford to replace all my appliances. And that didn't bear itself out in the data. But again, it was really hard because we didn't have specific households to look at. We had to look at across households. And so we have this cross-section variation that these things are sort of different. You bought the old town home for some reason. This guy bought a condo for some reason. So it's hard to say conditional on giving them both wealth if we'd get that same relationship. In terms of quality of life in water, that's a good question. And as someone who's done GPCD calculations for many, many ecoregions, I would say I don't know if that is if there's going to be a rule that sort of breaks out when quality of life plateaus based on water use, because it's already quite different depending on the region you're in. And what you do with your free time. I'm going to switch over to just rock gardens from now on. It'll be more time to go mountain biking. It'll be wonderful. Forget about these gardens.
Your survey in Idaho, Washington, I think it was really interesting that wildlife came up as like really, I mean, all the co-benefits, but wildlife in particular. And so I wonder how much that is because of recreational like opportunities and things like that, and how that characterizes. Because as you were talking about all these different studies, like I felt like I was drinking from a fire hose, because there's like so much information, but it's also like interesting how contextualized it would be. You know, would those co-benefits also be the case in West Virginia, you know, as something that would be of interest? So.
Yeah, I mean, from a scientific standpoint, I'm concerned about that study for its external validity, because I don't think those results will transfer very well. I would not use that study in like a benefit transfer method and say, look, it worked here, we should do it here. Just because I think the population around here is unique enough, the landscape is unique enough, I'd be concerned. But I was surprised also that wildlife habitat seems to be so strong, and recreation was actually relatively low. They were all very high, but recreation, the thing that I would care about the most, was one of the lowest.
Right.
Yeah.
I wonder if that has anything to do, just knowing at least northern Idaho. I mean, wildlife is a daily part of your life, and just the proximity of wildlife to daily life, maybe that.
Yeah, we're also one of the few states that hasn't seen a giant tail off in hunting. So if you look at hunting rates across time, number of active hunters per 100,000 people has been plummeting in every state, but Idaho's staying strong.
I would say maybe the hunters don't view their activity as recreational, but rather like in finding those wildlife, like the trout did. And
yeah.
So I should actually say you couldn't tell this because I was trying to blow through all these papers, but recreation, we actually gave some examples, and we included things like hiking, mountain biking, that kind of thing. We didn't say hunting in there, so maybe people did lump that into wildlife habitat. That actually makes sense to me.
Yeah. No. Interesting.
Yeah, and sorry, I know that was a lot of papers to go through in 45 minutes, but I was trying to give a whole retrospective of the last 5.5 years.
You've been busy.
Yeah.
And really, you were a latecomer on it, so you crunched a lot into a shorter period of time. Well,
I'm pre-tenure. I have to be productive still. Right, Meg?
Exactly right.
Yeah.
So based on all of your research, so all of these various studies and things like that, would you say that there are key striking themes as it applies to financing models for one water utility approaches? Like if you were to say like there were 3 things that you found that were most significant for financing, what would those be?
Sure. Well, I mean, just in terms of since I joined this project, I think that there's been a huge evolution of the acknowledgement of one water management, particularly in stormwater and green infrastructure. So I think that maybe that's the messaging around it. Certainly it seems to me, and I haven't done a paper around this, also I think that younger folks are more into that style of management generally, and I don't want to, this is being recorded, so I don't want to say that for sure, but at least anecdotally, I think that that's true. I think that my personal opinion is that people want all of the things for less. I think we have to make the communication that, yes, we can move this price lever, and that's one way, but also the service is a huge part of that. To go beyond the cost minimization of service provision and think about providing the additional services. We all like, let's say we all don't like, but I like to go for a walk in the woods. Now there's no dollar associated with it. That never shows up anywhere. But to have me internalize that and explain to me that that exists because of this fee for service model, because a lot of these things don't have a fee for service unless you make it part of it, right? And so I do think there's an appetite there. Our two of our papers where we sort of looked at this suggest that there is an appetite for a lot of homes. Now, I would say that we have to tailor that for those that are socioeconomically less fortunate, right? So maybe this is you know, some utilities have these differentiated bills. I don't know if that's the way to go, but I think there is an appetite for paying for those additional services. I mean, particularly, you know, we're living in van life nowadays, so I think that things are moving in that direction.
Thanks.
So maybe the messaging around kind of co-benefits, right?
Yeah, I think it's more okay to tie fee-for-service models to co-benefits than utilities have been traditionally comfortable doing.
Right.
And I mean, some of that is the gas fee stuff that you have to worry about, but I'm going to leave that to the people who are in the weeds on it. So.
I think it's interesting, the whole idea of the more for less as well, and how it could apply to maybe the use of gray water and things like that, because the expense of taking those through treatment, taking that gray water through treatment, and if you can find uses for it without needing to kind of infuse it with the cost of treatment.
Sure.
That could be an argument that could be presented. I mean, even in places, gray water technologies are getting better in terms of, or kind of the acceptance is getting better. So that might be something to think of.
Yeah, well, one of the things I always find funny out west is there's still a yuck factor. I mean, it's becoming more, but there's still a yuck factor from a lot of people, even though we know that if you look at a river and a watershed, the water is coming in, getting treated, popping back into the river. But as long as you can pull it out of the river, people think it's okay.
Right, because it's been diluted, right, with everything else.
Yeah, yeah. Hey, Sybil. Yeah, I don't know if I have particular insights in terms of the best financing methods. I do think that a lot of that stuff has actually sort of worked itself out since we started this project, which is nice. If you look at the implementation guide, it goes through a lot of those things in detail.
Cool.
Sybil, did you have something you wanted to add, or are you just saying hi?
I'm just saying hi. Good talk, Alex. Good to see you.
Yeah, it's great seeing you. Hopefully I'll come visit sometime in the semi-near future.
Hey, hydrology days, end of April. You should come out.
I'm actually part of our state water panel at the end of April.
Wonderful.
I get to lead a panel discussion.
Good for you. Spreading
Yeah,
those wings.
Apologize, I have to go.
Yeah.
Thank you very much, and we'll see you soon.
Yeah, nice seeing you.
Yeah.
Bye-bye.
Yeah, well, we are just about at the top of the hour, so thanks for your time, everybody. Thanks, Alex. It's always a pleasure hearing you bring some different perspectives to our somewhat engineering heavy conversations. Not all of them, because Ewan's not about that, but and it's always good to see you. So have a good afternoon, everybody. Hope to see you back.
And feel free to reach out if any of those papers you want more information. Feel free to reach out. I'm happy to talk about them.
Thank you very much. Appreciate your time.
Thanks. Good to see you, Christy.
Yeah, you too.
Okay, bye.